What's going on? Before we get started, be sure to like, subscribe, and hit that notification bell so you don't miss another video. Now, the profiler tools. Everyone's not so favorite mystery box of optimization. In the last video, we went through the optimization modes, breaking them down one by one, and today we'll be doing the same with the profiler tools, looking at both GPU and CPU, and breaking down what the various line items really mean. Now, there are a fair bit of videos on the profiler tools. However, you'll be hard pressed to really find one that actually breaks down what each line really means, what it is, and what you can even really do about it. However, that is exactly what we'll be doing today. Today isn't about me showing you how I get some massive jumps in frame rate because, as any true dev will tell you, barring obvious bad workflows and habits that require adjustments, optimization is really just a series of small steps to a target frame rate. And as such, I find much more value in going through and helping you to better understand the tools and break them down yourself so you're never stuck wondering what the heck it is you're actually even looking at. Now, before we jump in, I also want to give a quick community shout out to one of our Discord members, Kegs Effects, who recently released this amazing pack of highly customizable Niagara splashes. If you haven't checked them out, I highly recommend them. As we continue to build our platform, I think it's also important for me to mention that no community is about the individual. It's a group effort, and as such, I'll be making it more of a habit to support the community as much as I can, just as you all support me. Now, link to the Discord will be in the description down below. Now, let's not waste any more time. Let's go ahead and dive right into it. Now, before we jump into the profiler tools, I actually want to take a moment to go over something really important, and I hope you guys go ahead and start implementing this into your workflow, which is please look at the documentation. So we're going to look at some documentation and I'm going to explain as we go through it very quickly. I'm going to explain sort of why the documentation is so important. So first and foremost, here, for example, Lumen Performance Guide. So I know oftentimes there's requests for, how do I optimize Lumen, and how do we get Lumen to work well, and what's even the target frame rate supposed to be, and those kinds of questions. And I do have videos for that coming up. However, if you want to get a head start on that, it could be really beneficial to also look at the documentation and see what Epic themselves has to really say. So we'll just go over some of these just pretty quick. So for example, scalability settings, right? Especially if you're new to Unreal Engine, you might look at these and in your mind, all you really know is sort of these are the buttons I press to just like make things look better. And if you're a gamer, you probably have seen like, okay, well, shadows, global illumination, anti-aliasing, like, I've played with those settings in games, so, I kind of know what they do. But if you look at the documentation here, the scalability settings, just right here, for example, can be really important to look at, which is Epic here is really trying to get you into the mindset of what you can expect with Lumen. So cinematic is really just for cinematics, right? So if you're using Movie Render Queue, go ahead, use cinematic. Epic scalability level targets a 30 frame per second console budget. High scalability targets a 60 frame per second target budget. So why is this important? Oftentimes what I've seen is disappointment in how the engine is running, not because the engine isn't doing what it's supposed to be doing, but really because of expectation. I think especially going back and using like Unreal Engine 4, for example, we're accustomed to seeing like 90 frames per second, 120 frames per second, and that sort of being the baseline that we're seeing. And that's the sort of way in which, we used to look at frame rates. With Lumen, though, with everything being dynamic, with the GI and nanite, it does add an additional cost. And so with that, as of right now, the sort of target scalability that Epic is looking for is either going to be 60 frames on high or 30 frames on Epic. So keep that in mind, very, very important. So if you're on high settings and you want your game to be running 120 frames and it's hitting 60, for example, just know that it is actually doing what it's supposed to be doing. It might not be doing exactly what you want it to be doing, but it's what the engine is designed for, which is another great point, actually, when it comes to optimization. Sometimes the biggest question when it comes to optimization is the engine even right for you? So if you're looking to target a 120 frames or even higher than that frame rate for your game, which you can get in Unreal Engine 5, there's going to be a lot of limitations to it. But if that's what you're targeting, then Unreal Engine 5 probably isn't really right for you. And if you're looking to make a game that is, targeting that 120 frames per second, for example, it's probably not the kind of game anyway that Unreal Engine really has sort of tried to tailor make itself to really helping you to create, which are high quality, beautifully rendered, first person shooters and RPGs and open world, this, that, and the other. So I just wanted to throw that out there. The other really important aspect to the documentation is you can find really useful console variables here. And so for example, here, so let's say you're a developer and you want to release on a PlayStation 5, right? So here it gives you an example of like what that console variable would actually look like, what it would look like in your .ini file. And you can even copy this full snippet and just paste it into your ini so that you are using those actual PlayStation 5 settings. Obviously, there's a lot more that goes into it, but for Lumen, as we're here on the Lumen documentation page, it gets you a head start. Same thing with here, medium quality level, low quality level. What sort of techniques are you going to use? So the best thing you can really do when it comes to optimization and, learning what works, what doesn't work is really, looking at the documentation. Same thing with the virtual geometry here. So with Nanite, it again goes through the same thing. It sort of leverages what the expectations are with Nanite, how best to use Nanite, what situations does it work best in, when doesn't it work, how to enable Nanite, when to use different settings. So again, the documentation is really the best thing you can do when it comes to understanding these systems, especially Nanite and Lumen. They're still, relatively speaking, they're fairly new. It's only been out for about, 3 or 4 years. They're relatively new features. They're still being expanded on and support is still being built around it. And because of that, there's still a lot of sort of not commonly spread information out there, but it's all information that you can really find here. So just wanted to get that out of the way. Let's go ahead and jump into the engine. So here we are in editor, and as we can see, we're getting about 85 frames per second, and when I hit play, we're going to get about 60 or so. So it's 62, 63. In any case, the important note with this is that when we were just looking at the documentation and the Lumen documentation, we saw that at epic settings, you're going to be targeting 30 frames per second. At high settings, you're going to be targeting 60 frames per second. So the fact that we are in high settings and we are getting 60 plus frames per second is great. That means that we are sitting within that sweet spot that we want to be. And one note I really want to also hit as well is the frame rate in the editor doesn't really matter a whole lot. And what I mean by that is, yes, you want it to be running smooth, obviously, right? You want to be getting higher frames. You definitely don't want to be in the red, that's for sure. However, don't spend too much time splitting hairs between, for example, getting like the difference between like 83 and 87 frames per second in editor, right? Because the player isn't actually going to be seeing that. What the player is going to be seeing is what's the frame rate when you play the game. So that's the important thing. So yes, when you're an editor, of course you want things running smooth, but the most important thing is how is it running when you hit play. So just keep that in mind when you are optimizing, and it also keeps you in line with optimizing for the right things. So profiler tools. So we're going to be looking at GPU profiler as well as the trace insights to look at both the GPU and the CPU. So we're going to start first with the GPU profiler, and the way we're going to open that up is with Control Shift comma, and here we're going to get this graph here. So what you're going to want to first do is this duration, just double click on it to bring what's impacting you the most up to the top. And you can do this one of two ways, which is you can either click on this and it'll show you the scene, and you can hover over it to really just see if like there's anything sticking out that doesn't really make sense. And sometimes if you are seeing things that don't really make sense, one thing you could try doing, because when you're working with a game engine, it can do a million different weird things. Sometimes just exit and reopen and double check. For example, when I opened this the first time today, it said that my lights were impacting me by like 3 milliseconds. And then when I opened it again, that wasn't there. So sometimes the engine just sort of throws you red flags because it likes to be evil. So just keep that in mind. There are going to be sort of common culprits. When we are developing a game, when you're adding things to your scene, nothing's free. So everything is going to impact performance to some degree. So let's sort of go through these a little bit and sort of discuss what they are and kind of go through what you could do about it. So here under scene, I'm just going to use this, and we have base pass, nanite/visual buffer, diffuse, indirect, and AO, shadow pass, post-process, lumen scene lighting, volumetric clouds. Some of these are kind of self-explanatory, right? Like volumetric fog, we know what volumetric fog is, right? And sometimes you might have, if volumetric fog is high up, that means that either A, you might be just using too many local volume fogs, which could be a thing. You could have the actual like resolution of the fog. It might be too many samples, so you might just want to reduce some of those samples. And sometimes they'll kind of just tell you that, like this sort of grid here, 99 by 49 by 64, it's sort of telling you that. Translucency. So in my specific scene, for example, I'm looking at this translucency, and yeah, it's only hitting me for 0.33, and the distortion and everything after depth of field. So I could do one of two things. So in my specific scenario, which it's not, I don't want to get too deep into specifics because I'd rather show you guys how to use, like break down the tools itself. But for my specific scenario, I only really have the windows here on this church that are translucent. And the fact that they're costing that much isn't really what I want it to be doing. So what I could do is probably just turn the translucency settings to before depth of field, and it would probably just be fine. And if that didn't work, I would then take a look at them to see like if I need them to even really be translucent. In my specific case with these windows, they're kind of high up and you're not really going to see them. So like you're not going to see through them. So I probably don't even need translucency on them anyway. So for me, I would probably just turn translucency off. So just breaking down the thought process of like, how you would go about thinking about the decisions to make. But yeah, so some of these, again, kind of self-explanatory. Volumetric clouds, also hitting that. So I could just reduce the resolution of my volumetric clouds if that's something I want to do. Again, if you're hitting target frame rates, if you're doing good, then you might not have to worry so much about hitting these smaller things. But as I said in the beginning, optimization, especially if you're doing things right, and as you get deeper and deeper into it, it's going to be these small wins. It's going to be these like, reducing this 0.33 milliseconds to, like 0.1 milliseconds or something. It's going to be these accumulative wins that really start to add up. But yeah, volumetric clouds, lights. So with this directional light, 0.39 is going to be fine. If you have a lot more lights in your scene, they're going to be calculated under lights, right? You might have a bunch of spotlights. This might be your big pain point. More often than not, lights tend to be one of the bigger performance hits in a scene. And so if you have a scene, usually like an interior where you're going to have a lot of lights, whether they be like candle lights or whatever, this might be an area of contention. And so as you add lights, you might end up just reducing attenuation radiuses. You might end up turning cast shadows off for some of them, deleting some of them. So just keep that in mind. Everyone's GPU profiler is going to probably look a little different, which is why, I don't want to get too deep into like the specific fixes for like my problems, for example, right? So lumen scene lighting. If lumen scene lighting is causing you headaches, then you're going to want to probably reduce the quality settings especially if you've already preemptively come in here and like increase them. Definitely play around with those settings. Post process. So temporal super resolution, anti-aliasing quality equals 2. So that's equaling 0.64 milliseconds. So some of these, again, if you sort of use context clues, they can be kind of self-explanatory as to like what they do and sort of what the fix is. So this one, for example, temporal super resolution, and it's telling you, hey, the anti-aliasing quality is 2, and it's hitting you for this much. If, let's say, this is particularly high for your scene and you want to reduce it, then you can just type in, for example, anti-aliasing quality. And instead of 2, you could just reduce that down to 1, for example. And of course, like visually, it's gonna, you might see some changes within your scene. Hopefully the changes aren't gonna be too crazy, but when you like close this and reopen it, you'll see this number is going to reduce. Sometimes also your frame rate in the editor can sort of be progressive or adaptive, where it's not going to immediately sort of increase. So give it a second after you make some changes. You might not see like 5 frames jump up or something. So just going over that. But yeah, so temporal super resolution is temporal super resolution. It's going to tell you anti-aliasing, post-processing. Post-processing can sometimes be like pretty expensive depending on exactly what you're doing. All these different sort of effects like bloom, for example, lens flares, all of those fit into the equation. And if you're having issues with post-process, well, then usually the fix is to just go into your post-process volume, just click on bloom, for example, if bloom is giving you issues, and try turning it off, try turning it on, seeing if that fixes it, seeing if maybe like lens flares is hitting it too hard. Okay, so these are some of the more self-explanatory ones, right? So shadow depth. Shadow depth is really important, particularly this, render virtual shadow maps, render virtual shadow maps non-nanite. So virtual shadow maps really want you to use nanite. Even if you're using simple geometry, if you're going to be using virtual shadow maps, you want to be using nanite. And one of the reasons is because if you don't, then you're going to get an additional process on top of it. So for me, I'd have to go in and figure out like which assets are non-nanite, which ahead of time I already know which assets they are. They are the translucent assets. They are the water planes, the windows that are translucent, right? The assets for which nanite does not support, those are the ones that are going to be rendered non-nanite. However, this could be really important for perhaps your project if you're newly sort of transitioning assets to nanite, to sort of go into this and see like what, how is this affecting you? And if this number is really high, then you probably have a lot of assets that are not going to be, nanite. So keep that in mind, nanite, non-nanite. And some of these numbers also, the only way to fix, I will say, is to just like remove things, which we'll get into that in a second. So shadow depth is just how heavy virtual shadow maps are. So in total, the virtual shadow maps, the shadows in general, are hitting my scene for 1 millisecond, which is not really bad at all. That's pretty good. Diffuse, indirect, and AO. So these are actually all of your lumen settings. So lumen scene lightings, these are all of your lightings being calculated through lumen. Diffuse, indirect, and ambient occlusion. This is also the ambient occlusion. It's also the skylight. It's really basically, and it's also the screen probes for lumen. So this at 1.5 is probably fine, but if you wanted to sort of look at this, update radiance cache. So hardware ray tracing, for example, is on for my project. So as you go through this, you might see some of these things that just sort of pop out. Some of these you don't have to worry about too much, or at least you shouldn't. However, like pretty much all of these have some sort of console command, and the console commands are usually just like the name here. So keep that in mind. So if this, for example, filter radiance with gather somehow is like really high, then you can enter the console command and just change the value to reduce it. See what it does for your performance, see what it does for your scene. Usually that's going to be one of the first things you do. As I keep mentioning it, I do want to flag that as what you're going to commonly do when you're using Profiler is you're going to look at, some of these settings, like how I did with the anti-aliasing settings, right? And you're going to say, oh, well, anti-aliasing is kind of expensive. I wonder how many frames I get back if I just entered anti-aliasing quality, here, aliasing quality here. And, what would it look like if I reduced that to like 1 or even 0? Like, what would my scene look like? And what would my performance look like? And so it's going to be kind of a back and forth of doing just that sometimes, of just looking at this, saying, okay, well, this is kind of, hitting me kind of hard. I don't really want that. And turning things off and on, really. So you turn the lights off and on, see what it does. So here also hardware ray tracing. So again, for this scene, it's not too bad. However, what I'll probably end up doing is turning hardware ray tracing off, restarting the engine, seeing what it does for my scene, seeing A, how it looks, B, what the performance looks like, and seeing if it's really mandatory for me to even have it on for the project in the first place. So again, when you're going through here, if you see hardware ray tracing and it's hitting your scene pretty hard, then, go take a look at it, turn it off, turn it on, see how it works. Now, let's say you turn it off and you do get some frames back, but maybe you only got like a few frames and suddenly your scene just looks completely different, doesn't look that great. Optimization isn't just about getting rid of things, turning things off. Optimization is about the balance you create along the way. It's about balancing the visual fidelity with the performance constraints for the target console, the target hardware that you are aiming at. And so, so sometimes just turning things off isn't always worth it. You might get some frames back, but visually it might be too much of a degradation, and so you just want to turn it back on. Yeah, it might cost you a few milliseconds, a few frames, but for your specific game, it's going to be worth it. So you're going to look at optimizing elsewhere. So diffuse, indirect, ambient occlusion. This is going to be cumulatively like all your lights, all your sort of light effects, the ambient occlusion, things like that. And the nanite visual buffer is going to be all of your nanite. So main pass, post pass. So main pass, this is really just all the nanite. So here we are, SW, we have, software, rasterized patches, triangles, tessellated, and then hardware triangles. So we could turn hardware ray tracing off and reduce this one right here if we wanted. We got software, patches, triangles, tessellated. So tessellated is the displacement. When we are looking at rasterized tessellated, we're looking at how much displacement you have. So this might be, so in this scene, it's fine. At 0.24, for the performance we're getting right now, that's pretty fine. You can always play with, parallax occlusion mapping as well for your project. It might end up being a bit cheaper. If, let's say, you're using a lot of nanite displacement and it is costing you too much, then it might be worth it to reduce or to just remove nanite tessellation from like your landscape, for example, and then use some sort of relief mapping, some sort of parallax occlusion mapping instead, just so the displacement isn't hitting you so hard. So for example, in this scene, the only thing using nanite tessellation is the landscape. And the fact that just the landscape is hitting it for 0.24 it's fine, but I might also play with that myself for this project and try alternative methods to see if I can get that back. So that would be the fix there. So tessellated is going to be your nanite displacements. Triangles, patches, this is just your geometry and sort of how it's rendering that geometry. So some of this, there aren't really console commands to fix. When it comes to the lighting effects, if your issues are lighting and shadows, then 9 times out of 10, the fix for lighting and shadows is going to be reducing quality, whether it be through the post-process, like lumen quality, or changing the console variables to fit sort of lower numbers. The other thing is going to be sometimes you can't really do that. So like with nanite, for example, let's say we're looking at this and these numbers are way too high, right? All that means is that there's just too much nanite geometry in your scene, which if you're working in any sort of environment, you can't usually just have like millions, billions of geometry, right? Even before nanite, especially actually before nanite, you had to be really tactful with how much geometry you had in your scene, you know, where it was placed and all that stuff. But draw geometry, the only way to really fix this is just reduce the geometry. When it comes to things like foliage, you know, we went through this in the previous video about nanite foliage, but some of the fixes for that would just be, you know, like making the grass in this case, making some of them bigger and reducing the instances to reduce the amount of, you know, geometry that's being drawn through the nanite visual buffer. So that's GPU buffer. The other one, which is really important, is going to be the trace insights. So GPU buffer just shows you like what's hitting the GPU, right? And the trace buffer is going to, if I hit play, it's going to show you a bit of everything. So the way to do this is we're going to come down here to trace, and we're going to just hit start trace, and you're going to see this sort of record button pop on here. We're going to hit play, and we're going to start moving around in the scene. Okay, we're going to start running around and just jumping around and, you know, doing all sorts of stuff. Okay, and you're just going to run around for however long really you want it to be. And then once you're done doing that, just going to hit escape. And then we're going to stop this recording. Then from here, we're going to click on this, and we're going to click Unreal Insight Session Browser, and we're going to find that last session here, click Open Trace. And when you look at this, it might immediately come off as overwhelming. This is what's called a flame graph. And it might be called that because it kind of sets your eyes on fire when you first look at it. But I promise you, it's not as daunting as it appears. So first and foremost, we have all of these. These are all the processes that are happening. And this captures it across a timeline. So this tells us what was running at what time during that sort of recording that we just took. You can also go through it categorically here. And if you double click on things, it'll kind of take you to like where it is here. But what I usually tend to do is I'll actually go here to this timeline. And as we can see, we have some spikes. Now, some of these spikes are just when the engine was starting. So if I zoom in here, you know, we'll see it says that it's starting. And so this one, we don't really, you know, starting play in editor right here. So this isn't really one of the peaks that we want to really be focusing on, because this is just, again, when it started. So instead, I'm going to go, and this is where we ended it right here. So there's this one right here where it spiked up. So I want to know, why did my performance spike, right? So why am I getting stuttering issues, for example? One of the reasons you might be getting stuttering issues, just as a sidebar, is the shader compiling. So if you just have the game just pre-compute shaders ahead of time, you can alleviate a lot of the stuttering, but that's not what we're talking about right here. So if we click on this, it'll actually take us here where we can look at what exactly is going on. And so when I'm looking at this, I can see, for example, here that right here, a new process started and it hit my frame rate, right? Our performance dropped. And so what exactly was this? So this was a blueprint. So it's a UI. So what that tells me is that is most likely when I ran over here and I looked at our little cooking fire here, as it's something that we can actually, it's something that we can actually interact with. Yeah, there we go. We can actually cook with it right now. So that tells me when I'm looking at this that is what this was. So what does this mean? So really that just means that this UI had to load, and when it did, it sort of dropped the frame rate. So ultimately, a lot of these things would probably get fixed when we build the game. So that's when you sort of go through, sort of itemize, these issues and sort of see like what's going to get fixed at build, what isn't going to get fixed at build. So this is an issue that I'm not really going to worry too much about, as it's going to be something that we're going to be able to just fix when we build the game, as well as some other processes we're doing with it. But when we're looking at this, let's also look at what else is going on. So we see that, it loaded this blueprint, but there's also these processes that are taking a bit too long. So this, by the way, is sort of going in order, sort of breaking things down like into smaller and smaller pieces. So the engine loop is the engine loop. It's the engine running. We got the frame. So the frame, the world tick. And then it goes deeper and deeper, deeper. So, okay, character movement component, right? And so it's spiked up to this much at this point. Character movement component, collisions. So at this point, this is what's really affecting us. So when I'm looking at this, what I'm seeing, what this is telling me is there are some issues with the character itself, the performance of the character itself, that needs to be fine-tuned a bit. So it's parts of the blueprint that need to be optimized, right? And so, this could be really beneficial because this is not something that you're going to see in the GPU profiler, for example, or the view modes. So you might look through all the view modes. You might look at the GPU profiler, and you might still be getting low frames, or you might be getting stuttering or crazy frame rate drops, and you might not be able to figure out exactly why. This is perhaps the graph no one really wants to look at, and it's really the graph that you can, like, I always look at this one last. I always look at the overview modes first, then I look at GPU profiler, then I look at the insights here to see really what's going on. Generally, by the way, the insights is going to deal with a lot of blueprint stuff as far as like what's hitting your frame rate. I mean, as we can see here, we're not seeing like nanite draw geometry. We're not seeing, virtual shadow maps in here. We're seeing things that are impacting more so like the CPU. So these are things to keep in mind when you're looking at this. Yeah, you just want to click on these large frames and it'll generally tell you just like what is going on. Now, as far as what the specific fix is, that's really going to be up to you and the specific issue that you're running into. In this example, this is something that we're already aware of. It's something that we're actively, working on. It's all something that just, we're early on in development. So these are all things that get refined as we go anyway. But this can be really important. So again, we have the view modes, which we went over in the last video. We have the GPU profiler tools, which if we open it again, GPU profiler shows you how much time different processes are taking up. And we have diffuse, indirect, and ambient occlusion, which is going to be ultimately the accumulative lumen processes going on. We have the nanite visual buffer, which is all the geometry, post-processing, which is all the post-process effects, the base pass, shadow depth, and so on. So as you're doing this, as you're going through, all these processes will allow you and empower you to really optimize your game to the level at which you are looking for. So optimization, view modes, GPU profiler, trace insights, these are just some of the tools to empower you to optimize your game to the target benchmark that you are looking to achieve. That being said, optimization starts at inception. It begins with the idea, the assets, and follows throughout the entire development cycle. Sometimes it might just be that your asset simply doesn't perform well for whatever the reason, and it could be that the dense jungle you wanted for your game has to be reduced in scope, the number of NPCs just isn't really what you were hoping for, and so on. Game development is a series of compromises, and the bigger the task, oftentimes the bigger the compromise. Yet the beauty of that is creativity is born of necessity, and oftentimes the best ideas come from the worst luck. So if you find yourself in a rut, maybe you're realizing the scope has to change or specific aspects might have to be reduced, don't get too alarmed. That is simply part of the process. Instead, turn your mind to what creative solutions and ideas can you create in order to turn those compromises into strengths. Now that's it for this video. I hope you all enjoyed it. And until then, I'll see you guys in the next one.